তাহলে স্টার্টিংটা আমি করবো তো? Okay, hello everyone. So, welcome to the second chapter of the hardware department of JNX NSEC. Today's topic will be on microcontroller and microprocessors. Okay, there are certain informations for you from the beginning. All you have to do is you have to be very patient for today's webinar because, as you know, suddenly there was a storm hit, a little storm hit, and most of the places means the internet got scattered, and today's host is also unable to attend because his network is down. So even I don't know when I will get disconnected or not. So it's better you guys just hold your patience so that even if it gets disconnected, I will try my level best to connect once again at that very moment. Okay? So with that, let's start with our today's session. So today we will be talking about microcontrollers and microprocessors, right? What is a microcontroller or a microprocessor? Type of things which like if we take an example of our computer, then we know that there are impacts processing data that's required to perform any function or any type of arithmetic progression or any work that we give, and output devices are used to display the end result or to give out the end result in any format. It may be a maybe a soft copy like the displays or the hard copy like the prints. As you can see, microcontrollers and microprocessors being the brain of any system, it's not only about the computer but also even a simple MP3 player. It can range from your mobile charger to your mobile phone itself, your laptop, the camera, even the mouse. Everything contains a microcontroller or the components of a microcontroller. So, what will we learn today? We will not only learn, but we will come to know about computing, integrated circuit. Integrated circuit, yeah, it's a little bit interesting thing. Microcontrollers and the microprocessors, which are the two main focus of our today's topic. Integrated circuits are actually that consists of several logic gates and electronic circuits on a flat piece of chip. Well, integrated circuit is present everywhere. I mean, it is even present in your mobile phone, or I mean, in every circuit, the integrated chips are present. So, what are logic gates? Logic gates are actually those type of gates. I think most of you who have worked with computer science in your plus twos, or you are still working with computer science or anything like that, so you guys know what an logic gate is. Even if you haven't done anything about computer, means you are new, then to be honest, like, how to explain this logic gate thing? Logic gate is simply a gate which gives you like an addition, an exception, or even it can gives an AND gate. give an opposite relation. Like in the in the device stands only 0 and 1. So what these gates do, there are three main type of logics. One is AND, one is OR, another is NOT. The AND logic gate checks two input values and compares them with one another. If both the input values are 1, then its answer will be 1. And if either one of them is 0 or both is 0, then it will give you 0. Or logic gate is simply an additional logic gate. Like if any one of them is 1 or both of them are 1, then its result is 1. And if both of them are 0, then its result is 0. Now coming to the is NOR gate is the one which is like it gives you just the opposite result. If you give an input of 1, it will give you 0. If you give an input of 0, it will give you 1. Well, they are very complex to make you understand like this, but if we show them hands on, like how logic gates are and how logic gates are made using a pretty old breadboard and a few devices such as semiconductors, or what will I say? I will use diodes, not integrated circuits, but I will use diodes to show you what AND gate, OR gate, and NOT gate is. Then you will pretty well understand what it is. So, what you have to do is stay tuned in this channel because we will be posting certain hands on projects here in a different playlist. Okay. So, coming back to ICs. This integrated circuit chips are very advantageous because they are very smaller in size. Like their size can be from your palm top to a minimum size of your like nail, or even it can just fit on the top of your thumb or even your little finger. It's so small. Like sometimes you it's pretty well of size of a black ant, that those wood ants. It can be smaller than them too. Now, well, let's cut about the ants. They are very cheap to make and they have a better performance than basic circuits. Like basic circuits, when I say basic circuits, it means you have to make those wires made up of copper or aluminum, and they have been wrapped with those thick insulators, and the wire itself is thick, and it takes a lot of space to make, and there's a lot of cost for these things. Also a lot of heat is generated and resistance, and even there are noise if you go for any type of frequency circuit. But these things are all minimized by use of these integrated circuit chips. Now, what are these integrated circuits made up of? Integrated circuits are normally made up of semiconductor device like silicon, germanium. Well, germanium was used first, but later on silicon came into prevalence. Okay, there are two types of ICs present. At first, there used to be TTL, that is transistor logic circuits, which were used for the processors of mini computers and mainframe computers. Okay, so those were made of germanium mainly. But nowadays, what it is used is MOSFET IC, or metal oxide silicon semiconductor ICs, which are much more cheap, which are much more easier, means simpler and like easily available for all of us. So, and one of the advantage is that since this okay, one of the advantage is that since it is very readily available, so high density integrated circuits can be fabricated in a smaller place. And also p-n junction diodes are very much easier to fabricate than compared to any bipolar junction triodes. So what are this p-n junction diode or bipolar junction triode? We will come later on. Okay. So moving over to microcontrollers, one of the main thing of today's topic. Microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. A typical microcontroller includes a processor memory, input output peripherals on a single chip. It is similar but less sophisticated than a system on a chip. System on a chip may include microcontroller as one of its component. Like, okay, now what is a microcontroller? Let's elaborate. Microcontroller is a type of system on chip, or it is a type of integrated circuit, the ICs which we were talking about here. So microcontroller is a type of integrated circuit that contains valuable things such as the RAM itself, or like complex circuits like the RAM itself, or even the processor itself, so that a specific function can be done there. Like it's solely made to perform a specific task that's been engraved in there, or you can even code it. Well, the coding part, we will come to the coding part later on, but first let's talk about the sole purpose microcontrollers. The sole purpose microcontrollers actually consists of some type of logic gates connected throughout the pins. Like if you look at the integrated circuits, you can see there are four legs on each side of every ICs, right? So these are the output pins, and inside them, see, if you look at this picture, then you will come to know that that all those pins are connected to inside this memory chip. This is not a memory chip actually. It consists of different types of resistors, or you can say it consists of different types of diodes, triodes, which builds up an entire RAM, or which builds up just an entire system, mini brain or nano brains preferably. So this is actually a slaughtered integrated circuit, or a slaughtered microcontroller, and it looks exactly like this. Well, the size will be like, it's so small that actually this is even below a millimeter. This is even below a millimeter's range. So it's very complex to see. Now, microcontrollers play a very important role in forming of not only the computers but also everything. Like microcontroller is present in almost every electronic gadgets that you can see, ranging from your mobile charger to any toy that consists of just a motor rotating and some lights blinking. Even it consists of a microcontroller, and ranging from a wall clock, nowadays wall clock, to any digital thing. Any digital circuits always consist of a microcontroller. Like there can be no such digital circuit without a microcontroller, because microcontroller is the type of brain that is responsible for controlling that system. A very good example of microcontroller is your Arduino. Yes, the Arduino is a very good example of microcontroller. It has the integrated circuit, or the IC, Atmega 328PU inside it. Now that is the actual brain of the Arduino, and the entire Arduino board is actually a distribution. Like this picture, in this picture, you can see that that small microcomputer has a distribution pins laid all over, and those distribution pins create this type of legs. Okay, these legs are being soldered into any circuit. Now, if we think about Arduino, then this brain is that Atmega 328P. These are the wires that are spread out throughout the Arduino board, and the legs of these ICs is actually nothing but the output pins, or I mean the digital pins or analog pins or the power pins of the Arduino, right? Now, to code an integrated circuit chip, you need a special type of machine PLC language setup or a machine language type of setup. But Arduino makes it possible because its environment is such like that it can or it will automatically convert your language to that type of machine code, and it will embed it into the integrated circuit at Mega 328P. And according to the instruction that you give, Arduino will work on that way. It will create a brain, I mean a logical brain of its own inside the 328P. Suppose there is an example of the, let's take an example of the refrigerator again. From the last one. So there's a sensor which will check my content of milk. No, which will check the eggs, number of eggs present. Okay, there's a sensor that will check it. If the number of eggs are less than 3, then it will inform me to refill again. So in the code or in the instructions that I will give to the Arduino, I will tell it like, okay, so set up the code like, so set up the instructions like, if you like, if the number of eggs means you have to check for the number of eggs first, and if you see that the number of eggs is below 3, then you have to call me up and say, yo, your eggs are running out. But you can't do it like, means you can't say like this to the computer and the computer will understand, or this IC will understand. What you have to do is you have to write this thing in a pattern of code, like a pattern of a specific language or an order of language, and just upload it to the system or the system on chip. And that system is like, it will get converted into that machine language which the machine will understand. It's again that zeros and ones, the series of zeros and ones, and it will work according to the instruction it gets. So let's see what's next. Okay, microcontrollers are used in automatically controlled products and devices such as automobiles, engine control systems, implantable medical device like your pacemaker, just the similar type of thing which I said, remote controls, office machines, appliances, power tools, toys, and other embedded systems. By reducing the size and cost compared to the design that uses a separate microprocessor memory, an input or output device, microcontrollers make it economical to digitally control even more devices and processes. So, since microcontrollers, as you can see, the microcontrollers are spread out everywhere, means it is from our automobile to, even it can be planted inside our heart, not inside our heart but inside our body, from any pretty much remote control to any office printer or fax machine to your power tools like any type of, like the drilling machines. Well, yes, I opened my drilling machine and once I saw a system circuit on it too. Toys, as I said, the toys are also there. And as I have discussed before, like its size is very small compared to the other things and microprocessors. Well, I will come about microprocessors later. So since it's smaller and cheaper than the microprocessor, so it can be used that in any part, means in any place. I refer to any type of digital place like digital circuits or any type of digital complex machines which are here to work. Okay, so next we will be going to different types of microcontrollers. Now, as you can see, microcontrollers are just like our RAMs. RAM is actually, as you know, RAM is the random access memory that consists of your volatile informations that you can get from means that is actually the working things on the computer which is kept temporarily in a RAM, and it gets deleted if you erase it off. Let's forget about it. But what is inside a RAM is actually a type of array system which has been divided into this number of bits. Okay, so now this number of bits actually represent how much quantity of data it can acquire or it can hold at a pulse. There are 8-bit microcontrollers which can hold 8-bit of data at a pulse, and it can range to 64-bit. Now, this will enhance the power of the microcontroller. A 64-bit microcontroller, obviously having its power to hold much more data than compared to an 8-bit, is much more superior to that of that 8-bit, right? Well, there will be a detailed description about this again, and you have to wait for that hands-on experiment again, where we will be showing how 8-bit and 64-bit, no, 8-bit and 16-bit matters. And even you can make it at your home too, provided that you have the materials. So here's microprocessors. Before coming to microprocessor, let's see what's written there. Our microcontrollers come at fundamental elements of any digital storage system like RAM, GPU, CPU, etc. Yeah. Means microcontrollers come in part of CPU, obviously, and GPU also. Yeah, you can see like where the GPU is mainly located. It's also a microcontroller. Means microcontrollers are there also. RAM, as I said just now. Sorry for seeing your text late, Subrato Sarkar. Uh, RAMs even consists of this type of microcontrollers. Like microcontrollers are important parts of RAM too. Like the function of RAM is dependent on the microcontrollers, and you will be seeing the hands-on of the microcontroller too. Yeah, RAM is a type of microcontroller. No, RAM is a type of storage device that uses that IC microcontrollers, not to control but to store. Well, its controlling process is like that. It will take some information, and its processing is like keeping it, storing it until and unless the user asks for it. In that case, it's a microcontroller. I hope you can understand it now. Okay, so moving to microprocessors. As it's okay, now seeing this picture reminds me of my work with computer. Like, I remember when my motherboard got messed up and just got damped, so I took off this microprocessor. It was Intel i3, like somewhat an older generation. I took it and like kept it in a drive for a few months and ran it in one of my friend's computer, and wow, it was working perfectly. Like, both of us had the 64-bit architecture, and somehow it got matched. I have that microprocessor in front of me. Not only that one, but also of another old laptop which had a 32-bit architecture. So like they are pretty difficult to understand like what's inside. I will prefer you guys better not to cut it and see what's inside, because you will literally hate it if you see what's inside. So moving on to the microprocessors. Microprocessors are the electronic components that are used by a computer to do its work. As you can see, like in the advertisements where you see the processing speed is very fast because of this microprocessor. Then there's Snapdragon microprocessor for mobile phones. uh, there is that Apple's microprocessor, what's that, I forgot, something bionic chip, A12 bionic chip or something like that. Okay, so these microprocessors are actually those devices which are used by the device itself, like the mobile or computer or laptop, to do the work. It is a CPU on a single IC chip that contains millions of very small components to work together. Yeah, like you can see, like if you compare it to a CPU itself. So, like microprocessor is itself a CPU which consists of very like different types of things to work together. Like it consists of the arithmetic logic unit, it consists of register arrays and control units. I hope you guys know what are register array, control unit, and arithmetic logic unit. Register arrays is actually, register is also a type of memory like RAM. Well, registers are normally present. There's a difference between registers and RAM, is that RAM is volatile, but registers is not always volatile. And also, register has a capability of taking in data and giving out the data at a very fast speed. Most of the BIOS are, I think, I'm not much like into computers, but for a computer, I guess BIOS is installed in the registers of the microprocessors, because since it is the main part which is responsible for the starting of any computer or any device. So the drives and the connectors of those type of devices are always present in the registers, so that they can be easily accessed whenever the computer is started or whenever the device is turned on. So register array is a type of memory that's present inside this processor. It's nothing but a type of relay unit which will relay the data from one place to another. Yeah, it will store the data too, but it will relay it faster than any other parts. Okay, arithmetic logic unit. Arithmetic logic unit is the logical unit which performs all the calculations. Well, one more interesting thing about the computer is that, means the language of computer is that computer understands zeros and one, and number two is that computer understands only addition. It does not understand subtraction, it does not understand multiplication, division, integration, or anything. It understands only addition. It is by the virtue of this addition and reverse addition, it does subtraction and other things. So, arithmetic logic unit is also present, which calculates various results for you. The register array is the bonus part, which helps you to just relay the functions. And control unit is the thing that's responsible for controlling every data structures, and I mean data structures and data handling mainly. Well, the control unit, to be honest, I am not much into control units, or I'm not much into the arithmetic logic units or the registers arrays though. So they will be discussed later on. If you have any problem, then you can ping up. Like the central processing unit, microprocessors use three steps, commonly called fetch, decode, execute. Yeah, like Fetch is the part of the input function where it just takes in the data. Decode is the part of the processing function where the microprocessor's work comes into play, where the arithmetic logic unit comes into play, in fact, where it will decode your input and find the perfect or the nearby perfect result or anything that you want. And it will be executing that thing and giving you the final thing. Means it will give you the final answer that you need. In the fetch step, the instruction is copied from computer memory to the microprocessors. In decode, the microprocessor figures out what the operation and instruction is meant to do. In execute step, the operation is performed. Different computers have different type of instruction sets. That depends on the type of works that you have given it. Like they are different for working on any type of IoT project or any type of SoC project, or they are different even in playing games or listening to a music. So going to the next, we will be thinking about some examples, right? Like microcontroller, one of the topmost example that you know is your Arduino. For microprocessor, it's actually Raspberry. Oops, not this Raspberry. I mean, yeah, this one, Raspberry Pi. Raspberry Pi is is, you can say, it's the smallest computer. I guess no, it's not. There are even smaller computer than this too. Raspberry Pi. This is the picture of Raspberry Pi 3 Model B Plus, which is a very popular Raspberry Pi. I mean, most of the Raspberry owners have Raspberry Pi Model 3B Plus only. So as you can see, it has several GPIO pins. That is the input output pins, which will take in data and give you out data simultaneously. If you check the entire board, then you can see the Broadcom microprocessor present here, and these are all the microcontrollers. As you can see the pins here, right? These microcontrollers help the entire computer to perform various functions as required. So, well, you can understand more about this Raspberry Pi if you just like if you just see the overhead part of it. I mean, the the picture below. So I don't have it currently, so I can't show you guys, but you will really understand about the entire circuitry there. It's much more simplified than the one present in the top. So Raspberry Pi is just like a microcomputer where the power supply is from a 2 ampere for a 5 volt power supply. You can use your mobile charger if it's 2 ampere, and it will be a Type B charger. Here there's an audio cable where you can like plug in for audio for any type of sound or audio system. Here there's an HDMI cable. This HDMI port, sorry, not cable. This HDMI port is for connecting to any type of display device. Here there's an Ethernet connection so that you can get connected to Ethernet and like directly internet connection. There are 4 USB ports present here. Now, USB ports are actually for connecting your mouse or keyboard or any type of external device. You can just set up a memory stick, or even you can set up an external hard disk. Here, there is a camera slot and a display slot, which consists of its predefined means there are dedicated Raspberry Pi cameras and display units which you can set from here and use it. Like if you use those camera and display unit, then you don't have to means if you set that display unit, then you don't have to use an external unit for HDMI. If you set up this camera, then you don't need an external means you don't have to attach an external webcam or that type cam like that for any picture or video or something like that. No, I will not come to the details of Raspberry Pi here. but as you can see, so it is a type of CPU like your desktop or a laptop has, a generalized CPU. Oh, one more thing, it has a dedicated Bluetooth and a Wi-Fi device in itself. So like you can connect to any wireless network or via Bluetooth or Wi-Fi. So it's like a normal CPU with just the size is decreased with an additional Wi-Fi and Bluetooth and dedicated display and camera slot. And I think you can see these things common in any other computing device, such as I mean the laptops or the desktops present. To consider one more thing, these are actually slower than your normal computer. Its RAM is not I mean nowadays the Raspberry Pi have a RAM of 4 GB, but earlier, like this model is of 2017's model. 2017's model didn't have a 4 GB RAM. It didn't have a 1 GB RAM either. No, it had the 1 GB RAM after 2017. Like I was lucky enough to get the 1 GB RAM one in 2019 or 18 when I brought. I don't remember, but it was of 1 GB RAM. So nowadays Raspberry Pi are coming with 4 GB RAMs, which are much more faster than expected. So there's one more thing, the difference between microprocessors and microcontrollers, which is very important, and if you guys can keep it in your mind, then very good, or you guys may note it down after this live is over. Like you have to see this video once more again and just note them down. Microprocessors are actually brains of the computer system. Like the entire computer system has a brain of itself, where microcontroller is the brain. Like this is the entire computer system, where this Broadcom thing is the brain. Microcontroller is the brain of an embedded system. Now, embedded system MP3 player is not a computer system; it's an embedded system. But if you take but if you take an example of a calculator, it's a computer system, because calculator is used for performing many calculations, complex calculations, right? So it is the type of computing system. And embedded system example is your camera or any MP3 player or any gaming console. So microprocessor is a brain of a computer system, and microcontroller is a brain of an embedded system. Microprocessor, it is only a processor, so I guess its memory and input output are connected mostly externally. Input output systems are mostly connected externally here in microprocessors, but in microcontroller it has a processor with itself along with a memory and input output components. Like it's complex for you guys to understand, so I guess it's better to skip this way. Memory and input output has to be connected in microprocessors, so it is large. In microprocessors, normally microprocessors are processing units where it is solely used for processing and no other functions. So memory and any type of input output connections or the devices, I mean not the devices but the connections, had to be connected externally. But in case of a microcontroller, the memory and input output controls are present, so it is comparatively small. As you can see, in microcontroller it had those legs which were used as a connection of input output devices. Like in Arduino, those legs were being spread out to different sockets where it can be used as an input pin or an output pin. I mean input socket or an output socket. But in Raspberry Pi, those input output sockets that you can see are different. Now, in a microcontroller, it has a memory. It has its memory dedicated inside the chip. So it is basically like it does not need any extra load or any extra thing, and it's comparatively small. Microprocessors can't be used to make any type of compact systems, which is much more simpler in case of microcontroller. You can make a small PCB using microcontrollers, but a microprocessor for a microprocessor you have to make a large PCB where you have to just like set up that microprocessor in such a manner that it can be accessible everywhere throughout the PCB. So you can't since the microprocessor itself is much more big, so you can't expect to have a compact circuit with it. Now the cost of microprocessor is comparatively high. As you can see, the work function, performance function and everything is much more sophisticated and difficult than compared to a microcontroller, where microcontroller's function was to just relay an order and just execute that order, but microprocessors work is to work on that order too. So microprocessor doesn't have any type of RAM or ROM or timer clock or any other peripherals in it, but it as you saw in the Raspberry Pi, oops, not this Pi, as you saw in this Raspberry Pi, the microcontroller, the RAMs and everything is spread out throughout this entire board, irrespective of the microprocessor itself. But in an Arduino microcontroller, you can see that its main controller is Atmega 328P, where the Atmega 328P integrated circuit has the RAM inside it itself, the input output timer and everything inside it itself. So I guess there's no such fuss in working with it. Microprocessor speed is comparatively high than that of microcontroller because microprocessors are like its processing unit is much more faster, as it can as it they are built in such a way that they can work on various things at an instant, and they have at least their registers means they have registers much more than compared to the microcontrollers, which has just a normal array. Now now microcontrollers speed is like it can run up to 200 megahertz, but it depends on the architecture. Well, 200 megahertz is pretty much like it's very good for you guys, but it's not good when you come on any type of complex projects or any type of complex works. Well, it's much more simpler in case of microprocessors to attain a higher speed, as its clock is not dedicated one, but its clock is an external one, which you can, even if you want, can adjust it to like you can increase the clock speed if you want. You can overspeed the clock, which will result to a failure or a shorter lifetime of the microprocessor itself. But for that time being, it will provide you a very fast working experience. So these are the main differences of microprocessors and microcontrollers. Well, one more thing I would like to add up, that is microprocessor hands data and loads, whereas these microcontrollers are used for specific system applications. Like microcontrollers have a specific set of rules which are used for a specific function in a specific device. But for microprocessors, it is just like a brain. It will be creating all the rules for any work to perform. Like it can even change its rules, it can even alter its rules, it can even set its rule on its own depending on the parameters given, which microcontrollers can't do. Microcontrollers are set up for a sole purpose. I guess like it's almost time to say bye because there will be another one in 9:30. So I guess you guys must see that one too. Let's come to the conclusion. I know this one is a little bit weird, but the differences of microprocessors and microcontrollers can be understood only when if you see hands-on work with the microcontrollers and the microprocessors, without which it's not much easier to understand. Well, we are trying our level best, and we will be creating videos for the microcontrollers and the microprocessors and hands-on projects and hands-on works from the basic beginning. Let us jump back to today's starting where I said that I will be doing hands-on with logic gates, right? The and or not gates. So we will be starting hands-on with and or not gates in this channel. Well, there will be a separate playlist for this, and all you have to do is subscribe and just keep yourself notified for this channel. Another one more thing is that I have one of my own YouTube channel. It's the Harper's Cabin. You can check out. There's a link below. So Harper's Cabin is a channel which I created for this type of Arduino projects, and also you can get your information and answers, means whatever you want to know about any microcontrollers or microprocessors or how they work. We will be displaying several projects there and several like tech talks or a gadget talk where we will be discussing about any type of controller or a processor or anything that you want to know. So just subscribe to that channel, and like you keep yourself updated by pressing on the notification bar, means notification bell. And you can even write in the comments section about what you want to know in my next videos, so that I will try my level best to make a video about that particular thing that you want. Thank you for today's webinar. So let's meet you guys again in my next webinar. Okay, thank you.